Hi everybody. Today is Monday, April 13th. This is video number 4. This is going to go with quiz for quarter 4. The next 2 quizzes are only going to be 5 questions, and they're only going to be using the identities to simplify trig functions. On Monday next week, I'm going to take the identities a little bit further, but I think this week we're just going to concentrate on practicing these. So I have 3 more examples to show you. And you can refer to these as many times as you need to when you're doing the ALEKS quizzes. So the first example, I'll put up here. You have sine x cosecant x over cotangent x. So we have sine x cosecant x over cotangent x. Now a lot of times you switch these to sines and cosines. That's one of the first steps you usually try. But you don't always have to switch everything to sines and cosines. The sine and the cosecant I'm definitely going to. So I'm going to leave the sine of x, sine of x. The cosecant I'm going to write as 1 over sine because it's sine's partner. And then that cotangent of x, I'm not going to do anything to it yet. I'm just going to leave it as cotangent x. If you look at the sine of x and the 1 over sine of x, they're going to cancel each other out. Like that. And all you're going to be left with on the top of the fraction is a 1. On the bottom, you have the cotangent of x. And the reason I didn't switch the cotangent to sine and cosine is because I didn't need to, and it would have made the problem too complicated. When I get to 1 over cotangent x, I know that that is the same thing as tangent x, because they are partners. And if you can get it down to 1 trig function, which doesn't always happen, but if you can, you know you're done. Here's another example. This one's a little more complicated, but this way that we solve this problem happens a lot, and I think it's a good example. We have cosecant of theta, tangent of theta, and there's a minus in between them. Minus tangent of theta and sine theta. So with this problem, there's really not much I can do except change it to sines and cosines and then start looking for identities that'll help me simplify it. So that first thing is supposed to be cosecant of theta. So I'm going to change it to 1 over sine theta. Cosecant is 1 over sine. Tangent we know is sine over cosine. There's the first 2, I just changed them. Then I'm going to put my minus sign there. And the tangent, I'm going to change to sine and cosine again. And then that sine theta is already a sine, so I'm just going to leave it like that. And as always, I think it's a good idea if you put a 1 under something that's not a fraction when you're dealing with fractions. So that's what I have so far. I just changed everything to sines and cosines. So when I look at this thing, I have something that happens here. So the sines on this problem, the first expression, you see I have a sine on top and a sine on bottom? Those can go. So I cross those out. So I'm going to do a rewrite. This is now just a 1 over cosine theta because the sines canceled each other. Now this is the sine theta times the sine theta. That's sine squared. And then I have a cosine theta on the bottom. Okay, now here's the part that might be a little bit tricky for you, but this happens a lot. 1 minus sine squared is one of our identities. If you take the identity on your identity sheet, you have one that goes like this. It's cosine squared of theta plus sine squared of theta equals 1. I can rewrite that basic trig identity, which is on your sheet, by subtracting the sine squared of theta to the other side. And look what happens. I get cosine squared of theta equals 1 minus sine squared of theta. So by rewriting the identity that's on your sheet, I get a match. 1 minus sine squared theta is the same as cosine squared theta. I am going to use this for my next step. So I'm going to erase this. 1 minus sine squared of theta is the same thing as cosine squared theta. So I'm going to now write it cosine squared theta. And this is a common denominator, so I'm only going to write it once. Just a cosine theta. I don't have to write them both if I put it over one fraction bar. This one take away sine squared turned to cosine squared by the step I just showed you. Cosine squared over cosine, this means you have two cosines on top of one cosine. They'll cancel to just a cosine of theta and you're finished. That's a little trickier step, and that's why we're going to kind of take it slow and easy on these. But that's a common thing, taking an equation and rewriting it by rearranging the identities. I'm going to show you another one that's very similar. And this is the last example I'm going to show today. So it's a fraction. You have sine squared of theta plus cosine squared of theta all over 1 minus cosine squared of theta. So if I look at this one, sine squared of theta plus cosine squared of theta is one of your identities on your sheet. It's a Pythagorean identity. You'll see it in one of the boxes. Sine squared plus cosine squared is 1. This is 1. Don't even write it anymore. On the bottom, I have 1 minus cosine squared. I can rewrite that. 1 minus cosine squared is the same as sine squared. And I'll show you the step again. So I have sine squared plus cosine squared equals 1. That's their basic identity. It's called the Pythagorean identity. This is 1 minus cosine squared. So if I take that identity and I rewrite it, it's going to be sine squared. I'm subtracting the cosine squared to the other side. You get 1 minus cosine squared. And look at this. 1 minus cosine squared, 1 minus cosine squared. That means I can replace that with sine squared. So I'm going to do that. This became a 1. This became a sine squared theta. And I'm almost finished with it. I'm going to erase that step again. 1 over sine squared is a partner of cosecant. So I'm going to rewrite 1 over sine as cosecant squared theta. And it's finished. Just keep practicing these. The quizzes this week are really short. They're only 5, and they're identities, and that's it. There'll be 2 of them. And don't forget you have some quizzes that are due tonight. Thank you.